My name is Glen Clark DeLay. The last name is spelled capital D, small e, capital L-A-Y to make the name a name. There is a word called delay. And delay, don't do it now. This is not what I want. I want you to think of me as Glen Clark DeLay. Now, I'm going to be talking about 3 books. My first book is called Atom 1. Atom 1 will break down what I learned in 50 years. Now, after I have talked a little about Atom 1, I will then go into my second book, which is the internal structure of hydrogen and helium. I will fill you in why it is hydrogen and helium which starts everything. Then I go into the third book, which is the placement of the neutron with the proton and positon. The positon I created. There is no word in the chemistry books that reference to that. But the proton has more than one mass, so I have to give you some way of knowing the difference. Therefore, I created the word positon. And therefore, it needs an electron, which I now call a negatron. And all the 3 books cover this particular phenomenon so that you can understand what I'm about to talk about. Today, I'm going to give you a summary of what I have written, and it will cover the universe and Dr. Einstein. The universe is a study of stars, and we must then understand that there is a formula put out by Planck, and it is called Planck's constant. It is HF, and HF equals mc squared. In the formula that I'm to discuss will be E equals HF equals mc squared. The E stands for magnetic energy, the HF stands for H for Heisenberg, and the F stands for frequency. You're to understand that in order to have mass, you've got to have Heisenberg's formula first, because basically it has no mass. So how can you talk about mass if it doesn't exist using Heisenberg's formula HF? Now, I'm going to tell you that everything that vibrates has a frequency, and that is the F found in HF. And since Einstein gave us the formula c squared, you're going to have to understand why Einstein squared the speed of light. In the beginning, when Heisenberg first came up with his formula, it was to establish the beginning of the first mass. This particular phenomenon of creating mass using Heisenberg's formula is the beginning of all atoms, and you, the listener and viewer of this tape, must understand that Heisenberg gave us the beginning, and Einstein carried it forward from there. Heisenberg's formula created the first mass. We ended up with more mass until it reaches the value of 1.00867 atomic mass units. Now, in 12.5 minutes, that 1.00867 atomic mass units breaks down into hydrogen 1. Hydrogen 1 has no neutron. and it is the result of something changing from a big number into a smaller number. And if you don't understand that, you don't understand arithmetic. And I'm now going to give you a line of reasoning which takes that big number, 1.00867 atomic mass unit, and explaining how it becomes hydrogen 1 without neutrons. After I have done that, then I go to hydrogen 2 with 1 neutron, and then hydrogen 3 with 2 neutrons. Part of what I'm going to be talking about will be dealing with Einstein and Maxwell. These two individuals were talking about something called ether, and Maxwell gave it the fact that it does not consist of our 5 senses. And once we know that the 5 senses are real, but in ether they don't exist, you're going to have to understand what Einstein and them were looking for. And when they couldn't find it, they said it didn't exist. Well, it did exist, and I found it, and it consists of mass which has no magnetic field. If it has no magnetic field, we can't detect those 5 senses. That is what Einstein found, and he said ether didn't exist, but it does. Einstein was asked by other scientists, and sometimes not scientists, did he spend any time experimenting? And Einstein's answer to that question was no. I did most of mine by thinking. If you think through something, you don't necessarily have to do an experiment. And in so doing, Einstein gave us his theory of relativity, his theory of how things were created, and the stars and all of that. But he didn't do it experimentally. When Einstein did his mental thinking, he gave us E equals mc squared. This is an important formula, but not complete. Einstein said E, but he didn't say magnetic energy, which he should have. And then he gave us the equal sign and mc squared. He did not say how come the c, which is the speed of light, can be squared. If you, the person viewing this, were to ask yourself, if nothing can go faster than the speed of light, why did Einstein square the speed of light? This is what I'm trying to get at in this segment of the book and tape, and you are to understand that the squaring of c means that c is the speed of light, and the mass has reached that speed and is now gaining magnetic energy. One of the things which I want to emphasize is that Einstein said there is no such thing as fixed space. That means he is implying that space can move. I'm going to tell you that space cannot move. That which is in that space can move. And the information I'm giving here is that you're to think of the stars moving in space and the atoms themselves moving in space. In dealing with stars, we need to understand what a nova and a supernova is. That comes from Einstein's formula E equals mc squared. Einstein did not say magnetic energy, and he did not say that the energy explodes. We now will cover that part of it real quick because it is the thing that Einstein should have known but didn't. When he gave us E equals mc squared, and E became magnetic energy, and magnetic energy became in large volume such that the mass of whatever it is explodes, we have two phenomena to look at. The first phenomenon is whether or not the part of the star that exploded is still there. If it is still there, then it's a nova. If you look at it and see that the star that exploded is not there, then that's a supernova. The Crab Nebula that we can see through our telescopes is a nova. The white spot that can be identified as that which is left over after the explosion would obviously mean that part of the star is still there, and therefore it's a nova. If that dot, a bright light, wasn't there, it would have to be a supernova. One of the things that we have to understand is that because there may be a single star creating light, and our sun is such a star, we can, using a dark glass, look at the sun, and in so doing, we may see a solar flare which goes as a form of fire way out into space, and then it falls back. In so doing, it generates an electromagnetic phenomenon which comes from the sun to the earth as photons, and it takes 8.5 minutes for that photon to reach the earth. Upon reaching the earth, it causes the borealis at the North Pole to start to become highly active, and in so doing, it can actually blow up transformers in Canada. And if you understand that these photons are passing magnetic energy into our North and South Pole area, causing a great deal of magnetic energy to be generated. And that causes us to have problems with the North and South Poles as a unit destroying transformers found on the poles. We were talking about stars and atoms. There's one thing you have to take into consideration about an atom, and that is that it has a center point. And that center point is where the graviton is located. If the graviton is in the middle of an atom, then this graviton is the only thing it can do in attracting mass is to cause the whole atom to stay together as a unit. You're dealing with two types of combinations. One combination is a sphere, and the other combination is an electron rotating at right angles to a proton, and that the proton at its north and south poles have neutrons. And these rotate as a unit around the graviton. So you have all these shells and subshells given by Niels Bohr rotating as a unit around a graviton. And you have to think in two forms, whether it is a sphere in that form or a solid sphere. One of the problems that scientists have today is that they say that the electron has a negative charge and the proton has a positive charge. This is false. The charge that they're talking about is found in the space between the electron and the proton, or the negatron and the positon. And this charge is a single charge. The books give you the fact that there are two charges and they are equal. Well, if there's only one charge, it obviously is equal. So that's how they arrive at two charges when my book tells you via transformer action that there is only one charge found between the electron and proton, the negatron and positron. Now that you know something about space and the fact that that which is in the space can move, we're going to get involved in something which our top scientists use huge formulas to get at, which is a waste of time. All you need to do is to understand quantum mechanics using arithmetic. Now, in so doing, you're going to get involved with 5 basic numbers. There are 5 such quantum numbers, and all 5 of them are found inside Chadwick's neutron, which has 1.00867 atomic mass units. In 12.5 minutes, Chadwick's neutron changes into hydrogen 1, which has no neutrons. So don't confuse the fact that there are 2 types of neutrons. Chadwick's neutron I call 1 in 84. The 84 comes from the fact that Chadwick's 0.00867 loses that value. And when it does, it releases a negatron and loses 0.00029 atomic mass unit. And you must understand that this 29 number will appear as a quantum number. The 55 also appears as a quantum number, and it is the 3rd atomic quantum numbers that I'm going to give you. The proton has 1 electron, and sometimes I will say the proton is a positon and it has 1 negatron. The neutrons applied are called neutrons. I don't give them special names because it determines where they are found, top or bottom in a formula. And that's important, but that's another story. Now you're going to have to understand that the 4th value is that 0.00029 atomic mass unit already given. And it will appear in the different neutrons or protons and positons. So you already know about that one. Let's go to number 5. This number is 0.00002 atomic mass unit. Where does this 2 come from? In the case of hydrogen 3, which has 3.01605 atomic mass units, it is larger in mass than helium-3. And the difference in size is 0.00002 atomic mass unit. If you take helium-3 from hydrogen 3, you will end up with 0.00002 atomic mass units. And that's how that number 2 gets into the 5 quantum numbers. These 5 numbers can be combined to make compound quantum numbers. An example of a quantum compound number is the number 0.00217 atomic mass unit added to a like number of 0.00217 atomic mass unit to form 1 unit of 0.00434 atomic mass units. This is a quantum compound number. A second version of this is that we have the number 0.00100 atomic mass unit, which causes the electron to drop out of a proton. But that number can now be combined with the mass of the electron, which is 0.00055 atomic mass unit, and also include 0.00002 atomic mass units. The 0.00002 is the result of helium-3 dropping out of hydrogen-3. And when you combine these three, a compound quantum number of 157 is the result of combining 3 quantum numbers into 1 unit. Now that you're familiar with these quantum numbers, you're going to need to know some terminology, and one of them is isotopes. An isotope differs from one isotope to the other by the number of neutrons. And there is some confusion because Sir James Chadwick found that that mass had 1.00867 atomic mass units, and he called it a neutron, and yet hydrogen 2 and 3 and all other atoms, elements, or isotopes have neutrons. So the reason for me getting involved in neutrons is to keep you from misunderstanding Sir James Chadwick's neutron with the neutrons found in all other atoms except hydrogen 1, which has no neutrons. So in order to get involved in hydrogen 3, you're going to have to know exactly how hydrogen 2 is created from hydrogen 1, and then how hydrogen 3 is created from hydrogen 1 and 2. And then you get into helium-3, which is created from all those 3 isotopes of hydrogen, and you have only 1 neutron. Then after you get into that, you're going to get into helium-4, and helium-4 has 2 neutrons. In the case of hydrogen-3 has 1 proton and 2 neutrons. In the case of helium-3, it has 2 protons and 1 neutron. And in the case of helium-4, it has 2 protons and 2 neutrons. Now, you're going to have to understand that in dealing with the masses of the proton, you're going to find that you might have more mass in one case for the proton and in another case less mass. So how do you distinguish between them? You give them different names, and so I call the first one a proton and its electron. And then I say for the next one, it's a negatron combined with its proton, which is now a positon. Now that you know that there is such a thing as hydrogen 1, 2, and 3, and helium 3 and 4, there was a man named Niels Bohr. And Niels Bohr gave us shells and subshells. The shells were capital letters starting with K, and it goes K, L, M, N, O, P, Q, and R. There is no shell S or anything following it. But he then divided those shells up into subshells, and he labeled them in small letters S, P, D, and F. In the case of these small lettered subshells, Niels Bohr broke them down into the sequence at which they will be added to the different isotopes. And this part of it gets a little bit complicated, so you have to follow exactly what Niels Bohr said. And in my book, I go into that in detail. One thing that you're going to need to understand is my atomic charts of the elements. In most chemistry books, you have a Glen chart. And when Glen created this chart, he got the Nobel Prize for it, but nobody has updated it. My book updates it. And if you really get involved in understanding atoms, you're going to need this chart. And from this chart, I created 10 additional charts showing things that in some cases is known, and in other cases is positively not known, and they use Niels Bohr's shells and subshells, and I give the atomic mass units of all isotopes and their electrons, protons, and neutrons. I just said I give their masses. Most books don't do that. So you're going to get involved with exact masses. In this particular part of what I'm saying, that's too complicated to grasp real quick. There's more to it than I should go into at this point. But I will tell you that the atom hydrogen, which has only one neutron, takes into consideration the sequence following that. And then that follows into helium, that follows into other isotopes: hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon, etc. Now, if you're going to understand what Niels Bohr was talking about, you're going to have to be able to break down all isotopes and their subisotopes into numbering sequences that will allow you to know the masses of every one of the particles. That requires you to think, and it can be very difficult. After you have sort of gotten a little bit of understanding that there are shells and subshells, you're going to come across something in the chemistry books which they tell you is part of quantum mechanics. I'm going to tell you to be careful about saying it's part of. You got to say that this part that I'm going to talk about involves heat. And heat is not a quantum number. A quantum number will give you values that is caused by the proton and neutron. The neutron is involved with the proton in a way never known in any chemistry and physics book. And that's how heat is generated. It simply means that because they do not have the same mass, and the word they implies the proton and neutron, the positon and neutron. And they don't have the same mass, but they are connected to each other by their north and south pole. Up to now, all chemistry books just simply say that the two of them are combined, and they don't explain how this occurs. And in my book, I'm going to give it to you because of their north and south pole. And when they are together and rotating on a axis, they will generate heat. And this heat is what you see in the stars. It's what you see in atomic power plants. You see it everywhere around you. Rub your hands together and you generate heat. Well, it's not a quantum number. It is a mechanical number. And don't confuse the two. Even though I talk about mechanics as part of magnetic energy, it is the North and South Pole that gets involved in mechanics. Now, I told you that heat is generated by the fact that the proton or positon does not have the same mass as a neutron. But a neutron cannot be photographed because of its lack of a magnetic field, whereas the proton and positon, as well as electron and negatron, can be photographed. But you have to understand that you have a device called a TV set. In order to be able to see what's on the television, you have to understand that you're dealing with the movement of a ray of light that tells you that the atoms on the screen can reflect the frequency that is hitting that screen as it moves across the TV screen. This part of seeing something that shouldn't exist does exist and gives you the ability to understand that using the information given, the whole thing fits together as something we can use. A TV set is cold. Therefore, the beam or ray going across a TV screen will give you a picture based on the frequency of that which the broadcasting station broadcasts at. And if you want more information on that, then you should be turning to books on television, on radio, and learn more about the fact that if you move your hand in front of a TV set, just an inch or two away from it, you will feel the magnetic field. And in so doing, you're gaining knowledge of what's going on inside your TV set, which is the result of a station broadcasting all directions and arriving at your radio or TV antenna. And then that information goes through the mechanism that is built into your equipment and eventually ends up at something the eye can see and the ear can detect as sound. Up to now, I've been talking about the creation of hydrogen 1 from Sir James Chadwick's neutron, and that neutron has 1.00867 atomic mass units. It does not have to drop out as hydrogen 1. The hydrogen 1 is bypassed, and Chadwick's neutron turns directly into helium-4, and it loses 0.01520 atomic mass unit, and as such, the neutron found in helium-4 has 0.99347 atomic mass unit. This is a very important understanding for chemistry and physics and biology teachers, because it tells you what the neutron's masses are found inside a isotope of helium-4. Now, one thing peculiar showed up when I was dealing with my math or arithmetic, trying to get everything to be right. And I discovered that if that neutron loses some mass, which is 0.01520 atomic mass unit, then that Chadwick neutron changes into helium-4. It does not have to wait for 12 minutes to cause it to turn into hydrogen-1. It can go directly into helium-4. In dealing with hydrogen-3, we are dealing with a mass which does not have a percentage. Why then do we know that hydrogen-3 exists, and we know it has 3.01605 atomic mass units? And the reason we know it exists is because we're dealing with it in different occasions. So what is it that makes hydrogen-3 exist in all isotopes except hydrogen-1 and 2? In dealing with this, I don't really go into the detail that I could go into. But believe me, a isotope of hydrogen-1 with no neutrons then gains the ability to act as if it has both neutrons, or even just one neutron. And it acts like it's hydrogen-2 or hydrogen-3, even though it is not. Then you deal with hydrogen-2, which has one neutron, and it acts as if it is gaining a neutron from a nearby isotope. But there's a little trick to this. That single neutron acts as if it belonged to a nearby isotope which needs a neutron. Now, in hydrogen-3, it has two neutrons. So it then looks at a isotope on either side of it and shares its neutron with an isotope that doesn't have a neutron. Up to now, we have been talking about the distance between stars and the distance between atoms. In the case of the atoms, it's the distance between a electron and its proton, or a negatron and its positon. These distances must be there in order for the magnetic fields to cross each other. And in so crossing each other, these magnetic fields develop an electric charge, when we know it as electromagnetism. Now, the whole thing is based on transformer action. This is found in almost all books on electricity, but they don't go into any detail to the extent necessary on electronics. The people who deal with radio call it electricity. Those who deal with the TV call it electronics. What I'm trying to say in transformer action is where the magnetic fields cross each other. Now, what I'm about to say here isn't found in any chemistry book. You won't find it in any electronics book, but yet it is there, and it simply means that you can generate electricity in 3 different ways, and they are involved in vibrations, frequencies, and the ability to rotate on an axis, sending out magnetic waves, sending out a frequency which can be picked up, and sending a form of electricity which we know as electrical current. Electrical current in the textbook says it's caused by free electrons, and it is not. It's caused by transformer action, which causes magnetic energy to go the length of a copper wire, and in no way is involved in the movement of the electron through the wire. The movement is magnetism. And it is important to know that it is transformer action and not free electrons. This last part I gave you, called transformer action, is what all my books are about, and which is not in agreement with your textbooks. So don't go looking in your textbooks for transformer action, because they don't talk about it. I talk about it extensively because your understanding of what's in my books is based on transformer action, which is a electron next to a proton, a negatron next to a positon. And the control of this energy is the result of the neutron controlling the rotation of the proton. And since the proton and the neutron do not have the same mass, they must vary, and this variation shows up in the rotation of the proton on its axis relative to the electron rotating on its axis, all going in the same direction. In dealing with atoms, elements, and their ability to emit light and energy, we get into something which we call radiation. If we're dealing with radiation, which we call radioactive, then the amount of energy being emitted is very large, and it can cause great deal of trouble if caused to be brought together in such a form as to go boom, which we know as the atomic bomb and the hydrogen bomb. But radioactive is found in a lot of elements, including hydrogen-3. If hydrogen-3 has radioactive element to it, then you look at the fact that all isotopes have hydrogen-3 involved in it, then how can it be radioactive for helium-4 when it's non-radioactive? The answer to that is, how much energy does it contain? The more energy it contains, the more it can do things. And an explosion of such would be enormous. So we don't want to get confused with the fact that there may be atoms that don't have radioactivity and those that do have radioactivity. It's just how much they've got. In dealing with atoms, you're going to have occasion where you're going to be involved with something called X-rays. These rays, and remember the term rays, means it has no mass, means that there is energy being emitted by an atom, and that this ray can then penetrate almost anything we know. At one time, there was a scientist who discovered that his photographic plates, without an outside energy, being developed into something that showed a key, K-E-Y. And the discovery of this led to the idea that there is a penetrating type energy, and it was given the name X-rays. Now, if you have an X-ray piece of equipment which can take a picture of your bones, your teeth, and other solid items, then you have to know something about how this happens. And in the early days, the people used devices to give us X-rays, and they didn't know it was dangerous. And people began to develop cancer and things like that. Now, today, we don't necessarily use the equipment to generate X-rays. We generate X-rays to get the photograph, but the actual picture is digital. And the amount of energy to get that picture is infinitesimally small. No reason to be worried about what used to be the damage caused by X-rays. In dealing with my 3 books, you may not understand everything, but if you want to understand more than I've given, then you can order my books. There's one thing that I want you to understand about all of this, is that in dealing with personalities that are involved in what my book covers, I in no way am trying to run these people down. You read my book and understand that everybody is human. And as such, my book is supposed to give you the human viewpoint and the hard understanding arithmetic. In dealing with my books, you may want to cover more territory, and as such, you're going to need to order my book. And in my book, I will have drawings, lots and lots of drawings. And these drawings will, with the write-ups that go with them, you will then understand how it looks in the real world as well as the imaginary world. Drawings can do this. And all of this can be found in my charts that can be viewed on the website. I want to thank everybody who viewed my tape on this, and that they have an open mind and can attempt to understand it.